Hello and welcome to this session on replacing your Edge Gateway. I'm thrilled to be here with you today to speak about Edge Gateway, which is an essential component for exposing your applications for external consumption. Your choice of gateway makes a huge difference in terms of the use cases you can deliver and your future expansion. We will discuss how a simple upgrade of your Edge Gateway can help you deliver significantly more business value. My name is Jad Savek. I am a field engineer at solo.io, where I am engaging with organizations to help progress their application modernization journey. I have 15 plus years of experience in infrastructure, networking, and security technologies. In the past 3 years, I have been focused on cloud-native application connectivity and security using CNI technologies, service mesh, and API gateway. Let's start with an introduction to set the stage for our discussion. In the past few years, we have seen a significant increase in organizations adopting cloud-native practices. Kubernetes has become the de facto standard for deploying cloud-native applications in a variety of environments. Microservices architecture is now considered the modern way of building applications. And with that comes a lot of opportunity for accelerating innovation, but also challenges in achieving the aspired outcomes. Complexity is one of the biggest challenges to cloud-native initiatives. A simple communication flow for a monolith application becomes an exponentially complex communication map when stripped to the constituent microservices. Many solutions and practices have emerged to help manage the complexity. Service mesh, for instance, can help manage the complexity of the communication of distributed applications based on microservices. GitOps practices have become a standard for simplifying and standardizing, automating application deployment and configuration. Let's zoom into the Edge Gateway, which is the topic for our session. Once your applications are deployed to your clusters, you need a mechanism to make those applications available for external consumption. This consolidated gateway into your applications provides an opportunity to reduce the complexity of your setup and to deliver more business value. We will be exploring some of the key use cases that you can accomplish through your Edge Gateway. Let's first have a quick look at the options for exposing your application in Kubernetes. The basic option is service of type node port, which effectively implements layer 4 port address translation, mapping the Kubernetes service port to a unique port on the Kubernetes host. The approach is static and does not scale in a cloud-native deployment. Another approach is service of type load balancer, which uses node port under the hood, but leverages Kubernetes Cloud Controller Manager for creating and updating an external load balancer. This would require a separate load balancer instance per service and requires all security and traffic management use cases to be implemented within the application or elsewhere in the architecture. This approach is, again, not scalable in a cloud-native application deployment. Next is the Ingress Gateway, which solves some of the challenges related to exposing applications via a single gate. It allows for routing to different services based on domain names, and it can use the same load balancer instance for multiple domains, which is cost effective, and it can also deliver basic security and traffic management use cases. The fourth option that we're discussing, which is the focus of our discussion here, is API Gateway. It is the most feature-rich option for modern distributed applications and can deliver advanced use cases for traffic management, security, and observability as well. It can implement features like service discovery, authentication and authorization, resilience patterns, canary releases, rate limiting, and many more, all of which would have otherwise required the application to implement them in the application code itself, with all the complexity that comes with it. There are many reasons why you might consider replacing your existing gateway with a more modern and feature-rich API gateway. It might be that your existing gateway cannot meet your traffic management and security and observability requirements. It might be that implementing such features in your applications across different teams, different development languages and frameworks in your organization has become complex, and you want to abstract those functions from the business logic of your applications. Your organization might be planning on including new features like WebAssembly as part of your application delivery. Or you might be looking for leveraging GraphQL to provide a more efficient and scalable use of your APIs. Your existing gateway might be lacking the flexibility to connect to services external to your cluster, such as serverless functions. Or it might be that your current gateway does not natively integrate with your service mesh, or might not support GitOps configuration to integrate within your automation workflows. No matter what the reasons are, I invite you to consider optimizing the business value you extract out of an essential component that's sitting strategically at the edge of your clusters. In the next few slides, we will explore some of the business cases that you can deliver in upgrading your edge gateway. We will start with traffic management, then security, then observability use cases. Let's first look at traffic management use cases. Deploying cloud-native applications requires the flexibility in routing to services. An essential foundational requirement for your edge gateway to effectively route traffic to services in your cluster and beyond is service discovery, which can maintain an accurate picture of services deployment at any point in time. Your edge gateway should also have the flexibility to support progressive releasing of services at the edge, which is a common pattern for reducing the blast radius when you're updating your services, and the risk that they might introduce unintended outcomes. Approaches for controlling service releases might include canary deployment, blue-green deployment, traffic shadowing, or others. For instance, canary releases is a common pattern where a new version of the service is introduced and traffic is gradually migrated to it to ensure proper operation. Blue-green implements a typical copy of the environment, while traffic shadowing allows for creating a copy of requests and sending them to a new version of a given service for production testing, for example. Your edge gateway is in the perfect position to facilitate those use cases. It is sitting at the edge and can simplify your setup by implementing the configuration declaratively as part of the continuous delivery tools and without any changes to the application code. Resilience is another essential requirement for application deployment to preserve functionality in case of service failure. You should expect from your edge gateway to be able to implement resilience patterns and abstract them from the business logic of your applications. Key use cases, for instance, may include the implementation and tuning of request timeouts, retries, circuit breaking, or even simulate fault injections to determine your application behavior under abnormal conditions. Examples of fault scenarios may include introducing delay, for instance, or errors with some HTTP status code for a certain percentage of the requests to determine the application performance under those conditions. Also, modern applications might require a variety of request transformations to achieve the business cases. Let's look at some examples of common transformations. One simple example is HTTP request redirection to HTTPS to ensure all application requests are secure and encrypted. Another simple example of transformation is rewriting the request prefix, which allows for the modification of the prefix for communication with your cluster services, for instance. More complex transformation may include header transformation, such as adding or removing a header. A typical use case of such transformation is the extraction of JOT information, which allows for routing to services based on identity, for instance, or the implementation of authorization policies accordingly. Transformations can also be used, can also include transforming the request type, for example, from gRPC to REST, or vice versa. Or it might include supporting the implementation of new features like GraphQL and WebAssembly. Such transformations that might be essential for delivering the business use cases are hard to implement as part of the application code and might even require infrastructure on their own to deliver. Looking at your gateway to handle those transformations can add a lot of value with a limited effort and without adding complexity to your setup. Let's look next at some of the security use cases. A foundation for securing your application is encrypting the requests using TLS. Depending on your security requirements, you might need to implement mutual TLS, where the validation of the request is happening not only for the server, but also for the client request. Your gateway can help terminate those TLS connections for different applications. This means that it should carry the certificates required for encryption and identity validation, which can be delivered as Kubernetes secrets, for instance. It should also support service name identification to determine what certificate to serve depending on the domain the client is requesting. Your gateway is the gate for the outside world to access the various applications and services within your cluster, whether there are monoliths, microservices, serverless functions, etc. In microservices or hybrid application architecture, any number of those workloads need to accept incoming requests from external clients. Incoming requests may require authentication to validate and establish the client identity, but also the servers they are requesting, and to define any access or traffic control policies accordingly. Examples might include routing to specific services based on user or group identity, or implementing granular access control based on identity. You might equally have a different routing and access control requirement for your authenticated versus your unauthenticated users. Your gateway can offload those authentication capabilities that otherwise would have needed to be implemented in your application code. Your gateway should support also different type of authentication methods that are required by your business units. Common examples might include OIDC, SAML, JOT, and needs to support also different backend identity providers. Let's look a little bit at threat prevention. Your gateway requires as well the implementation of controls to prevent common threats. For sure, security is distributed responsibility across multiple layers within your architecture, but your edge gateway should play its role in threat prevention from its unique position at the gate for your application access. For instance, authorization policies can help implement Layer 7 controls to secure access to internal services with granular matching for destination path or method, or even the source, which can be based on the user ID information from extracted from the authentication. A gateway can help implement WAF functionality, web application firewall, which can help protect your application by monitoring and filtering and blocking potentially harmful traffic and attacks that can exploit your application. WAF can do this by intercepting and inspecting the network packets against known threats, can be tuned based on single or group of applications basis. Exposing your applications also opens the door for numerous incoming requests to your application. And this requires implementing global rate limiting per application and becomes crucial for ensuring the quality of service of your application. This should work in synergy with authentication to define separate rate limit policies for authorized or unauthorized users. Those are some controls that you are most probably implementing in other places in your environment, but should consider consolidating and implementing them at the gateway level as it is in the perfect position of enforcing them. Finally, let's look at some additional considerations. An important consideration is observability. It is critical for monitoring your application's performance and to be able to pinpoint and troubleshoot application performance issues. You might already have tools in your environment for application performance monitoring. Those tools might rely on telemetry and tracing information received along the application or the request path. Your gateway can provide rich information at the entry point to your application. This information should include metrics, access logs, and traffic and tracing information for your application. This information can then be scraped, analyzed, and used for reporting or alerting using tools like Prometheus, Grafana, Kiali, and any observability tool that you can that you have in your environment and can ingest this information, correlate it, and report and alert on it. We cannot talk about cloud-native applications and not discuss multi-cluster, which is becoming multi-cluster deployment, which is becoming a common pattern. As your cloud-native application deployment matures, you might find that you need to support multi-cluster application deployment to meet your business high availability or scalability requirements. You might also find that service mesh is becoming an integral part and the requirement for you to meet your connectivity and security requirements. Your edge gateway is an integral part of your environment and should be capable of natively integrating within your service mesh so that it can meet your organization traffic management and security requirements. In multi-cluster deployment scenarios, your gateway might play a bigger role than just governing north-south communication or acting as the external gate to your applications. The gateway might be playing east-west a role in east-west communication and becoming the gate for multi-cluster services communication depending on the use cases. So those are some of the things that as you scale, you want to make sure that your gateways integrates well within your service mesh and can support also your multi-cluster deployment and different scenarios that might include north-south and east-west gateways as well. Now that we have spoken about key use cases that your edge gateway can help deliver, and that upgrading to an API gateway can help deliver, let's talk how our portfolio can help you upgrade your edge gateway functionality and deliver true API gateway capabilities. Solo.io's portfolio includes a comprehensive solution that can meet your north-south and east-west use cases. You see here that it includes Glue Edge, Glue Mesh, and additional extensions on top of them. Glue Edge is a standalone modern API gateway based on Envoy that is packed with features to meet a broad range of use cases. We have developed tons of filters that can be implemented as chains and deliver all of those use cases that we have discussed. Glue Mesh is a service mesh management solution that solves the complexity problem of managing meshes in distributed environments and includes Glue Mesh Gateway as well, which packs similar features to Glue Edge within the mesh, leveraging the Istio Ingress Gateway. All those features can be delivered via a declarative configuration that fits perfectly in your automated GitOps workflow. So whether you need a standalone gateway that can deliver quick wins and deliver quick business value, or a gateway integrated within your mesh, we got you covered. We are engaging with large customer base that is helping us improve our product and shape our roadmap to align with real business problems. We have made the bet early, a few years ago, built our technology on Envoy, based on Envoy, for valid reasons. It's driven by a neutral foundation, the CNCF, like Kubernetes, so its roadmap isn't driven by a single vendor. It has a large, diverse, vibrant, open source community, which we are an active contributor in. It's extremely efficient, highly performant software written in C++. More importantly, if you have already adopted or you're going to adopt a service mesh in the future, chances are high that this service mesh will be Istio. And if it's not the case, it will most probably be a service mesh based on Envoy. So choosing an API gateway that speaks the same language based on Envoy will allow you to get the metric for your API gateway and your service mesh in the same format. And this way you can troubleshoot issues in a common way, and it will make your life much easier and provides native integration. You can see here the extended feature set packed in Glue Edge, which covers the key use cases we have spoken about in this session and way beyond. Migrating to Glue Edge can deliver quick value for your business, can help you achieve your edge traffic management, security, and observability requirements, and can help your developers focus on the business logic of the application and delegate additional features to the API gateway. The migration strategy might differ depending on your setup and requirements. But the one message I want to send here is that migrating to Glue Edge is very simple. A simple strategy that we have seen working is the deployment of your Glue Edge gateway in parallel with your current existing gateway. In this case, both gateways can coexist and point to the same services. You can then set up different domain aliases for testing purposes. Once you validate your gateway is performing as expected, you can switch a given domain for your traffic to go through your Glue Edge gateway. This process can be repeated in testing, staging, and prod to ensure a smooth transition in all environments. I invite you to install it. It's quite simple. We have extended documentation, provide details about the installation, and give it a try. It's free, it's open source, and feel free to reach out to us. We're always available if you need any help. I want to thank you for attending this session. I hope you got some new ideas on how to leverage a modern API gateway like Glue Edge to deliver more business value for in your environment. And I hope you try it soon and give us your feedback and engage with us. Thank you.